Hello, everybody. Welcome to, thank you. Welcome to Advanced Editor Scripting. I'm Yilmaz Kiymaz. I'm an independent game developer from Istanbul. I actually gave this talk last year at Unite 2012 as well, but a lot of people after the conference on Twitter said they really liked the content of it, so I revised the talk and resubmitted it this year, and here I am. So what I'd like to do first is get an understanding of how many people in the audience have worked with editor tools before. Could you raise your hand if you worked with it or written an editor tool before in any shape or form? Okay, put your hands down. And how about people who haven't worked with editor tools before and are completely new to it? Just a few people, okay. But even for those few people, part of the mission for this talk is to make you see just how powerful editor tools are and why you really should spend some time on making your own editor tools to make your life easier when developing your projects. Also throughout the talk, if you have a question at any point in time, just raise your hand, and if I see you and I call on you, then there's a microphone over there and a microphone stand over there. Please move to those microphone stands so everyone can hear your question better. So let's get started. Last year, I kind of categorized editor tools into several different categories, but this year I want to make it a bit more freeform. So let's start with asset postprocessors. Let's quickly take a look at the documentation for asset postprocessors. Okay, so asset postprocessors let you hook into the import pipeline, and anytime a new asset comes into the Unity project or is moved in the Unity project or is deleted from the Unity project, you get specific callbacks in your asset postprocessor script, which is very handy and saves you a lot of time by automating the import settings of certain assets or modifying certain assets after they've been imported. So let's take a look at the callbacks that we receive. The most important ones are right here. There is the pre-process callbacks on pre-processed texture, model, audio, and then there are the post-process callbacks. We got texture, model, audio, game object, and then all assets as well. And then we have a few other things we can use. So recently, I was developing a game for an airline, a golf game, because there was a golf tournament happening in that country, and I had to use asset postprocessors to really kind of make the golf course meshes that were given to me by the artist ready to be used in the game automatically. Like there were 30, 40 golf courses, and I didn't want to hand adjust them to be runtime compatible. So let's take a look at that real quick. So this is the golf course right here. Can I make this full screen? That's the model. That's the raw model that I get from the artist. It has a bunch of foliage, and it's got the ground piece, which is actually the most important piece where the collisions happen and everything. But the thing is, the artist really wanted to keep the ground in one piece. So he didn't want to separate it into several different objects because it would have been difficult for him to work with the vertices of several different objects together, move them around, and texture them, etc. So the ground object is right here, hole 02, and it has about 7 or so materials on it. So it's one mesh with 7 materials on it, which we know is trouble for Unity because that means 7 times the draw calls, and especially if you're trying to use mesh colliders on this thing, I don't want to add one big mesh collider to this. I want to be able to separate it out into little pieces for performance reasons, right? So the way I solve this is with an asset postprocessor. Let's take a look at what that does. Okay, can everyone see the code fine? Okay. So here's our golf course processor, which inherits from asset postprocessor. And we have some constant settings here that we keep that really don't need to change throughout the project all that much. The first thing we're going to look at is the pre-processing of the model. So the way This callback gets called anytime a model gets imported into Unity. But for me to know whether it's a golf course or not, the way I do that is by looking at the path of the asset. So in an asset postprocessor, you can access the asset importer, and that has the asset path, the path of the asset that's being imported for this callback. And then we check whether that asset path starts with a specific string, and that is right here, assets, golf, models, golf courses. And if you look in the editor, that's where our golf course model is actually located, golf models, golf courses. And then any model file that I put in here will jump over this if check, and then we cast the asset importer into a model importer so we can actually set the different import settings of the model importer. So we do several things. We make sure it doesn't add a collider of its own because we're going to divide this thing up and add colliders ourselves. We turn off animations because we don't need them. As for secondary UV, we need light map UVs, and they weren't provided to me by the artist, so I enable the light map UVs. However, that can take a really long time, so for this presentation, I set the generate light map UVs Boolean to false so that that doesn't happen. We set the model scale, the material settings, mesh compression, et cetera, and then once the preprocessor callback is completed and then Unity does its own import business, then we get a post-process model callback, which is right here, and we get past the game object. Any questions so far? This is going to get a bit more complex. So once again we do the asset path check, we go into create process model prefab method. We take the current time to calculate how long this whole process is going to take, and then we do some initializations, but I'll get to the real meat of the stuff real soon. So we get all the mesh filter components within the model we were passed because the meshes are what we're interested in. That's what we're going to process. And for each of the meshes, shared meshes of the mesh filters, we call process mesh in model. And here, as you saw in the editor, let's actually instantiate a copy of this thing in the scene and kind of get rid of all the extra stuff for now. Oops. Okay, there it is. One big mesh. Unity exposes the submeshes to us, luckily. Otherwise, I wouldn't have been able to do this. We check whether the submesh count of the mesh that we just got is more than one. And if it is, then it's our job to divide it into those submeshes. I have a method called getSeparated_submeshes that completely encapsulates the process of separating those meshes out. What we do basically is iterate over the submesh count, get the triangles of the submesh, and then create a list of the vertex indices of that submesh, and then we kind of map the indices from the monolithic huge mesh to the single separate submeshes. So we create the mesh data structures, copy the data over, fix the triangle and index vertices, and then create the new mesh object, and then we return the array. Afterwards, then we step through all the separated submeshes, and the reason for this is as follows. I have a quick editor tool that I wrote that can kind of step-by-step do this process to help me debug it, because that process, it really does a lot of things, and keeping track of all of them could be difficult. Here it is, golf course processing tester. So I can call that specific method to separate into submeshes right here with this whole 02 selected, click the button, and then delete the original. And now the mesh has been separated into its submeshes depending on where the materials were assigned to which triangles. But I actually want to go a step further. For example, there are these three pieces right here, all of them assigned the T-box material, but I want to separate them as well into, and I call these mesh islands. There might be a better term for this, but I want to separate the islands apart as well. So that's what we're doing next. We have a method called getSeparatedMeshIslands, and what that does, in a little overview, is as long as the vertex count is greater than 0, we keep going through the vertices, finding the islands, taking them out, then looking through the rest of the mesh and taking out each island one by one. And I have a little debugging routine here for this. I have a step-by-step mesh island separation button where I can kind of watch the process as it happens step by step. What we basically do is we just take the first vertex, and then we look at all the triangles of the mesh and find the triangles that use that vertex, and then add the other vertices of that triangle into a list. And then we keep doing this as we grow the vertices that can encapsulate the whole island, and then we take out that island. So if we click it, we got some red debug lines here that you see. These were the first vertices that it found, starting with the 0th index vertex. And then we keep clicking, and then it found all of them. If we click again, it's going to take that island out. And then we do it again, and then that's the last one. We do it again. Now, these have been separated into mesh islands. So now what I can do, now that I have kind of divided this mesh into the way I want to have it at runtime, I can go ahead and add my mesh colliders to it and set its layers and so on, which is what I do next. So for each separated mesh island, what we actually do, this was an important point that I skipped over. So there's the original model file. We don't really want to overwrite that, right? So that should stay as is. We want to create a new prefab where all these modifications are saved. So we go ahead and create a new prefab, and that's where we actually copy all the mesh data and the game objects. So that's what we're doing. We create a new game object for this specific mesh island, and then we add a mesh filter, set the mesh. If there is a matching physics material corresponding to the material, render material name of the mesh, then we go ahead and link that physics material in, and then we add this to a list so that at the end of this whole process, we can just save this out to a prefab. If there were no submeshes, then we just copy the mesh as is with no changes. And if we go back to our original method, create process model prefab, after we've processed all the meshes, we create a new prefab, and then that prefab might already exist. So right now, there is a process prefab that exists in the scene. If I were to re-import, since it exists, I need to delete everything in it first and then add the new meshes in. We go ahead and destroy immediate all the things in it, and then we add all the processed game objects into it, and that's pretty much it. So we go from, let's reset our scene. We go from this original raw mesh where this ground is just one piece into a processed mesh where the ground has been separated and mesh colliders have been added and their physics materials have also been added. Any questions so far? No? Okay, let's move on. Another thing I didn't get to show last time at my talk, but I want to show this time, is scene view visualization. So when you're developing things in the editor, sometimes it helps to have extra visualization in the scene view of the data that you're creating in your scripts. I found that to be quite useful. So here's a game that I made with my girlfriend a while ago. We didn't get to release it. It's just a prototype, where you try to grow clouds by leading other clouds into this original piece in the center. So clouds come in from the sides. They kind of go not in the direction of our cloud, but we can lead them in by creating these wind pathways. And then if they get close enough, they stick, so you kind of keep growing this cloud. So this wind effect took a while to create, but the thing that really helped debug the issues that I had in the beginning was the scene view. If you take a look at the wind vector field, as I draw with my mouse, you can see the wind vectors get set, and then after a set amount of time, those vectors get lerped back to 0. So whenever I had, I drew a wind path with my mouse, but the movement of the cloud wasn't matching, I looked here, see if there was anything wrong, and then I could go do some further debugging to see what was the problem. So the way this is achieved is really simple. Let's take a look at wind vector field. The only methods responsible for drawing this in the scene view is onDrawGizmoSelected, which you might be familiar with. When the game object that the script is on is selected, then we go ahead and execute this method. And as long as our wind field is not null and visualize field boolean is checked, then we just draw some lines in the scene view. And this is pretty simple, but for better visualization tools in the scene view, there is something we can use called OnScene GUI, which is what I'm going to show next. So this Polyline script is something I actually got from the Unify wiki. The author of it was community member Toffeetooth. I don't know his real name, that's his handle. But as you can see, we have a control here within the scene view to kind of add points to our polygon line. So we go ahead and click insert. We get one point in there. We can click it and move it around. We can click insert again and again. We can insert after. We can insert before, in the middle. And then we can just kind of move this around. It's probably best if I go into isometric view. And then you can keep making your polygon like this. And the thing that I find this really useful for is if I'm prototyping a game and I don't have a 3D artist at my disposal, if I want to make some kind of ground mesh, I just quickly use something like this to create a polygon and then just extrude a mesh out of it on awake, for example. I also use this in the golf game where when the ball, where we define the out of bounds areas of the golf course, we use the same thing here. Let's take a look at this script. So as you can see, the Polyline class itself, the one we use at runtime, is just a list of vector3 positions. So all the clever work that's being done is being done by the editor script, unlike before, the scene view visualization was actually inside the runtime script, and it was just on draw gizmo selected. So let's take a look at Polyline Editor. So this is mostly the code that I pulled from the Unify wiki, but I made some modifications to it, such as making it loop. The last vertex is connected to the first vertex, and so on. But it's got some really neat things in there. For example, to hide the default handle. So if you go back here, we have a game object selected, but the handle, movement handle for that game object is not actually showing. Even if I select the move tool, only the move handle for the vertex that I clicked on is showing. But there's a selection button here that I can click, show main transform, and I can move this guy around. And then I can reset the transform while keeping the vertices where they are in world space and so on. But I can hide it, go around, change it some more. And if I were to accidentally, if I weren't in isometric view per se, move this up in the y-axis, then there's a control here to just reset the y back to 0. It's really handy. So what it does is on enable, which I find to be a great entry method for a lot of things, not just for editor script, but also for runtime, just kind of do your initializations in. It makes sure that the script that we're targeting with this editor script has its positions list initialized. And then in on-scene GUI is where the magic happens. So for each position in the polygon line, we draw a handle. And I kind of changed how this works from the original, and I hope to put it up on the Unify wiki as a modification at some point. We draw a button, and using the sphere cap method of the handles class as the drawing method for that button. And then we use that button to determine which vertex was clicked, so we can draw a gizmo for it and move it around and so on. And then there's a method for drawing the scene GUI controls. And that's the one that's responsible for drawing this area right here. And it's pretty simple, just like drawing any kind of immediate mode GUI in your game. You set your GUI labels, GUI buttons, etc. But the good thing that you can do with your editor tools is always use the undo system. So whenever you do an operation, if you want to undo, just call undo, register undo, give it the target that changed with your operation, and then give it some kind of string to show in the undo menu if you want to. That's pretty much it for this one. Any questions? Okay, moving on. Data generation for runtime. This is something new that I did this year in the golf game. I don't know if you've ever played golf games on PC or mobile, but there's a power bar that appears when you're about to take your swing, and the user just presses the button to stop the power bar going up and down at some point, and then that's the power at which the ball is shot. The problem is the golf clubs have a range, and the power bar 0 to 1 needs to match that range, like 20 yards to 200 yards, let's say. But I don't know the internal physics calculation that happens to make the ball go to a certain distance given a certain force to start with. And if I were a very mathematically fluent person, I probably could find that out, but I kind of found an easier way to kind of fake it with an editor tool. they're useful for everything, so let's take a look. So this is just a scene with a really large plane, and then we have the tiny golf ball all the way over here, waiting to be launched by our editor script. And if we click on the golf club range calibration game object, it has an editor script which changes how the inspector is drawn. And we have a button to begin the test right here. We select the clubs to be calibrated, and when we click begin test, it goes ahead and does its thing where you can see the ball being thrown. Basically what it does is it chooses a random force to shoot the ball with, and then looks at where it lands, and then it keeps iterating over by dividing the force or multiplying the force that it was shot with to make sure that it lands where we want it to land according to where the power bar maps to the distance. And you can tell it what accuracy you want it to get within. So for now, for it to just go smoothly, I just entered 0.9. So you can see the debug log out here. We're shooting the golf ball with the driver club at 0.7 power. The velocity magnitude equals to this. And then we look at the desired distance we want to get to, and we look at what distance we achieved. And if the accuracy is lower than the desired accuracy, then we just keep iterating over until we get the desired accuracy. And then what we do is we store the data for what velocity we should be using at which power level into an animation curve. So at the end of this process, let's find the golf club's prefab. Maybe it's not there. Oh, right. Right here. So this is where all the club statistics are stored. So for the driver club, we have the name type, etc. It has a drive range of 20 yards or to 240 yards. I might be wrong on that. I'm not good on imperial units. It's converted to meters anyways, but here's the velocity curve that we use. And this is sampled at runtime to kind of choose the right velocity for the ball to be shot at. Now the thing is we have about 10 clubs, and the number of steps we take to create the animation curve is 10. And so that could take a while for it to just, if the time scale was just 1, it could take a while for the ball to go there, for the accuracy to be calculated, do it again and again. So what I just do in this editor script is I set the time scale to something like 10. So the whole thing goes faster, and if you don't set the time scale to some really crazy value like 1,000,000, then it doesn't seem to deviate off the actual calculation if the time scale were 1 by that much. So where do I set the time scale? Right there, okay, test time scale is 10. So most of the parameters that you see here are actually stored in the runtime script, golf club range calibration, and the editor is responsible for selecting which clubs are to be calibrated when you begin the test, and when it detects that the test has ended, then it copies over the data that it generated into the prefab. Okay, so the examples I've shown so far have been some of the more involved editor scripts I wrote in the last year, but you don't have to write really huge editor scripts to take advantage of the power they give you to really speed up your workflow and kind of improve your quality of life when you're working on your project. So just really tiny and efficient editor scripts can also really do wonders. So let's take a look at some of the examples for those. So panel activator, let's bring that up. This was another kids game that I was working on with my girlfriend where we have different panels for different numbers, and you teach the kids what the numbers are with the objects that are on the screen. And the way this is set up is it's using Angui, and each number has its own panel. So for me to go and edit number 2's panel, I'd have to, for cleanliness, uncheck, disable the number 10 panel, go ahead and enable number 2, mess around with this, then disable it, enable 3. Gets really tiring really fast. So just a really tiny editor script can help with this problem. Let me bring it up. There you go, number panels activator. 1, 2, 3, 4, 5, or click next in previous. All it does is disable the currently active game object panel hierarchy and enable the one we want. So it's really simple, but it just kind of saves you a lot of time. When you think about the number of times you have to do this operation, it just makes sense to write an editor script for it. I'm not even sure there's anything worthwhile in the code, but let's take a look. On enable, or whenever the editor window gets focus, we reobtain the number panels that are in the scene. We find it with GameObject.find, parse the numbers that the children have over here to kind of sort them. And then in onGUI of the editor window, we just do an iteration to draw these toggles. And then we check which one we unchecked, which one we want to check, and then we go ahead and disable and enable for that scenario. I don't know why my slides keep going back here. Next up, I have another small script called replace selection with prefabs. In this scene, initially what I did, stupidly, was each one of these rockets was a non-prefab game object, and I set the audio clips on all of them. Because now that we have multi-object editing, it was really easy. I could select all of them, drag the audio clip in, but then doing these changes again and again was difficult. It would be much better if I could just change the stuff from prefab, right? So instead of kind of manually copying in the prefab, putting it at the right position, and then hooking stuff up again, just wrote a little editor script that replaces the selection in the hierarchy with the prefab selected in the project view. And this one doesn't have an editor window. It's just a method in a scriptable object. But let me take a look here. So let's say these weren't prefabbed. They are at the moment. I could select them and then select the prefab in the project view. Unfortunately, you can't see the menu bar at the top, but I'm going to Window, Tools, Replace Selection with Prefab. You know, this was a bad example because we didn't even see that they get replaced. Let's do it with another one. Replace the fish with rockets. There you go. So pretty simple editor script, but saves you so much time. Now the trick here with the multiple selections, both in the project view and the hierarchy view, is to filter your selections so you know which ones are the game objects in your hierarchy and which one is the asset that you selected in the project view. And as you can see, it's just 30 lines. We get the prefab by getting a filtered selection of type game object, and the selection mode is only for assets. And then, if I remember correctly, selection get filtered will return an array of the selections, but we only want one object. So we do a find call on that list, and we return the first thing that the asset database says is a main asset. And then we've got our prefab. If the prefab isn't there, don't do anything. And then we get our scene transforms by doing, again, a selection get filtered call. And then they should be of type transform, and we want to exclude the prefabs. And we add a register undo here before we do our operation, and then we go ahead and do the destroy and the instantiation of the prefab. Another really simple one, and this is the last one, is the bounds aligner. When I was working on a project where I think I rolled my own GUI solution with some 3D planes with textures on them, I wanted to be able to kind of snap things together, and they weren't necessarily at the right, I wasn't using the right unit size, like not everything was 1 meters wide, so that I could just use a snapping feature of Unity. This is to align the bounds of several different objects. So we go ahead and create a cube. And then let's create a sphere. And let's say the sphere is over here, the cube is over here. Let me bring up the editor window. Okay, here's our bounds aligner editor window. Let's dock it here. We set and render A to be the cube, render B to be the sphere, and then we align the x max of the sphere to the x min or bounds position or the edge of the other one. We hit align, and then the minimum x over here of the cube is aligned to the maximum x of the sphere over here. Obviously, in this scenario, it doesn't seem very useful, but when you're making GUI and you're kind of trying to align things just right, it kind of comes in handy. And then I just added the 2 buttons here for the configurations I use the most. I could just do that instead of trying to find the right configuration over here. Any questions so far? Okay. So now that we have the asset store, and even before the asset store, people were kind of distributing and selling different packages and solutions to things. Now that the asset store is out there, a lot of us are using third-party solutions for a lot of things, right? So we use ngui for UI, or 2D Toolkit for our 2D games, and all the different combinations. And sometimes they work for you just fine, but most of the times I find that for your specific use case, they can have some little shortcomings that can be easily fixed, but sometimes it's hard to find the courage to just kind of go in and mess with them, and then you think, well, if they upgrade to the next version, how am I going to merge it? But I think the benefits outweigh the other things. What are they? Disadvantages, let's say. And so don't be afraid to extend third-party packages, and let's take a look at an example of that. Sprite Stepper. I can actually show you this one, but I don't have the example scene for it, unfortunately, but I can kind of explain to you what it does. Let's take a look at the code. So what this is about is we were using 2D Toolkit for a distance running game, and the frames of the animation, so let's say we have a monkey running and there are 10 frames of him running. We were also in conjunction with the sprite animation using a regular Unity animation to just kind of move the guy around on the screen additionally due to some problem in our workflow. So this was to sync the 0 to 10 frames of the sprite animation with the normalized time of the Unity animation. So that's what it did. And the thing is, there wasn't direct access to set the time for the animation window, so we had to resort to reflection. So let's take a look at that. I actually don't remember what this tool looks like, so let's bring it up. Here we go, Sprite Stepper. You would drag in the 2D Toolkit sprite in here, and then the animation window, if it were open, the tool would also detect that. And then we could click these buttons to go to the next frame in the sprite animation, and the animation window would automatically go to the proper time of the animation loaded there. So the way that's achieved is by stepping in directions. We get the sprite definition and figure out how many frames of sprites there are, etc. And once we've found the time that we want to jump to, which is, I think it's sprite index multiplied by the animation step size, we get the editor assembly. From the editor assembly, we get access to the animation window type. And then we get the animation window object by calling editor window get window and pass it the type of the animation window. And if the animation window is not null, as in it's actually up there, we get the preview frame method from the animation window type by doing get method and giving it the option to do full binding, which basically means give me all the methods there are, regardless of whether they're public, whether they're private, static, etc. And then we go ahead and invoke this method on the animation window object with some parameters that need to be passed in as an array of objects. And in this case, it's just a float value, or maybe it's an int, where we calculate and tell it where to go. The other one was ngui. I used ngui extensively in 2 projects now, and there were a few things where I thought maybe I could have some editor tools that kind of help me do, shrink several manual tasks into just one button click. For example, if you have your ngui sprite type set to sliced instead of simple, clicking the Make Pixel Perfect button doesn't actually set the sprite size according to the texture size. So I just had a Make Simple and Pixel Perfect button here where it would set the sprite type to simple and then call Make Pixel Perfect on it. For some reason, I think it's a bug, the button collider size would always be set to 144, 144 on the box collider. So I just clicked this button to kind of fix that. When I was reworking atlases, when moving one sprite from one atlas to another atlas, if I wanted to quickly change the atlas on a bunch of sprites, because NGUI's editors don't support multi-object editing, I had a little thing here where I drag in the atlas, click set atlas, and so on. And then by default, NGUI's buttons have a tint to them. And in this game, we didn't want any tints for hover or press or anything like that, so we have a button here for setting button colors to white. So Sion Rosenblum, some of you might know him of 3 Sprockets, who's done Cuban 1.2 and is now working on Fight the Dragon, has given me a really cool tip. It's a really small thing, but I think it just kind of enriches my life as an editor developer, where if I just click this button, I can get a console output in color. So you can stylize your console output however you want, because recently, I think in the 4X lineup of versions, somewhere along the line, they added GUI text.reach text option. Let's take a look at the documentation for that one. Oops. Trying to zoom in. There we go. So if you enable rich text for GUI text, which by default is enabled for the console, you can enable HTML style tags for your text. And you can also do this for the console, where in there I just set a color property on the thing that I was, let's take a look, the hello text that I was debugging, logging to the console. There you go. Just put a little color tag in front of it, hello, and the color tag, and then it's the color that you want. You can make it bold, italicized, et cetera, et cetera. Okay, so what I want to do now is actually kind of involve you in a little bit. I've been doing editor scripting for a few years, and I have had many crazy ideas about the different kind of editor scripts you could make. Like in the talk description, you might have seen one day I want it to be possible that I can just press the power button on my computer and have it boot straight into Unity OS. So I can just do all my stuff in there. And actually, last year, if you attended my session, you might have seen that I tried to make a web browser inside of Unity. And the problem last year was the URL bar didn't work. I couldn't get the focus away from the web view. So I think I can now. Yeah, it took me a year to get the URL bar to work, but it works. So soon, hopefully, it'll be on the asset store. It's not yet, but I will provide you with a link to the resources used in this presentation at the end of the presentation, and then I will be updating that page once we all get back from Unite, and then the link to this one will be there as well. And it's going to crash. Oh. Anyways. So this was one of the crazy ideas I had, where when I saw that the asset store window was in Unity, and I realized that it was just rendering a web page, I thought, why can't we render any web page? Wouldn't it be really cool if you just clicked the button in the editor and it brought up the documentation for you within the editor? So the way this was done, and I tried to live code it last year, which went horribly, is using reflection to get access to the web view type, and then setting the URL that the web view uses to display this content to any kind of URL you want. Very quickly, I can show you here. Right, so there's a load URL method we get from the web view type, and we just call invoke on it. call it on the web view that we have, and pass it the URL text, and it just loads that URL. It's pretty simple in that case. But actually turning it into a web browser where you can scroll properly, you have a URL bar, and maybe history and tabs and all that kind of stuff is much more difficult, and hopefully I'll get to that in the future. What I want to know is if anyone in the audience has some really crazy ideas like that they've been meaning to do or start with some other people but haven't had the chance. So, Devin, if you can go to one of the microphones over there.
That's cool, I can just yell.
Okay, I'll repeat your, what you said.
So it would be really nice if we could point at any GUI object that appeared in Unity and use that to give tutorials to users of Unity. So being able to stick an arrow in front of something or put a highlight over something would be a fantastic way of showing people how to use the tool.
Great idea. So what Devin said is that it would be great if we could put highlights or arrows next to any kind of GUI element within the editor so that we can make tutorials for people. Let's say they want to learn about terrain. You can make a step-by-step tutorial perhaps that says click here with an arrow and just kind of walk them through it instead of having to switch between a video in your browser and, unless you have two monitors, Unity. Any other crazy ideas? Yes.
I have often wished that I could make really fast changes to scripts inside the Unity editor. So if I'm missing a semicolon or something, if I could just click in the editor and add it there and have that save.
Right. So I might be mistaken, but I think there's a solution for an in-editor code editor. Does anyone know the name? It's out there, right? So, sorry? Unity IDE, I think that's it, you're right. Let's take a quick look. So this is the other thing I wanted to happen is, let's say you have this crazy idea, but maybe it's already been implemented by someone, so you can just start using it today. Let's see if it's on the asset store, Unity IDE. No. There we go. It's an editor window where you can go into any specific script that you have in your project and you can edit it right there and there. So perfect, exactly what you were asking for. Beautiful, no problem. Who else has a really crazy editor script idea? Yes, sir.
It's not that crazy, but maybe there's a way to do this that I don't know of, but it'd be really nice if instead of having just the draw default inspector to draw the whole default inspector, if I could call some method to draw the default inspector for a specific section or element of whatever class I'm inspecting, but then have custom stuff to do the rest of it.
Yeah, exactly.
Yeah, you can do that now.
How do I do that now?
Well, not exactly. You can actually say, I want to draw this specific thing different.
Well, yeah, no. So the example I was specifically thinking of was drawing some sort of advanced list editor where I could change the way that the list was displayed, but draw the default inspector for each element of the list.
Right.
By the way, can people over there hear when someone over here talks? No, so that's why we have to use the microphones, guys. We really need to get up there and use the microphones. Anyone else? Floor is open. Anything you've been meaning to implement, maybe not necessarily related to a project that you already have, but just something you think would be really cool? Yes.
I've been meaning to kind of circumvent the terrain system and paint, say, a bunch of trees that turn up as physical game objects so that I have a higher degree of control over all those objects.
Gotcha. But do you still want it to use the tree system of the terrain to do swaying and such?
I thought that I could just add a wind system and because they're created with the tree creator, they would still work.
So
the issue is that when they are a part of the terrain, I can't access an individual tree and modify it by script in any sort of way.
True.
Especially
well, actually, I think there is a way to modify it by script, but I don't know if it's editor only, but you have to use reflection to get to the tree instances, and then you can kind of set them, I think.
Oh, okay.
But I hear what you're saying. And I don't think it would be that difficult. A while ago, actually back when I was just starting with Unity, I wrote something called an object painter where you drag in a prefab and then you click in the scene view and you do a raycast to see where you clicked and it just spawns that prefab there. So if you had like a bunch of tree prefabs, you could just paint over the terrain and then have all your trees be separate game objects. The problem there is if you have a lot of game objects, then that could be problematic for rendering and performance purposes. That's why there's like a tree system where you can't really modify the positions and all the other parameters of the trees. But if it works for your case, why not? Yes.
I've been wondering, I mostly am focused on my scripts in my game. And when I'm in that mode, I hate clicking around in my folders. So I'd like to have like a solution explorer like you would get in, say, Visual Studio or Monodevelop in my editor to open up my scripts and make it easier for me to see what I'm doing all the time instead of going through all my prefabs and all
Are you saying within the Unity editor or within Monodevelop?
Within the Unity editor.
Okay, so you want to be able to jump to a specific script right away instead of trying to go through the folders? I see. So I think one way, well, obviously this Unity editor tool that we're seeing here gets access to all the scripts in your scene by looking at the folder hierarchy. One thing you could do is use the get all asset paths method, I think. So I don't think it's in the documentation, but there's a method and it's public. You don't have to use reflection to access it. There's a method such called get all asset paths or something similar. And what it does, it just gives you the path to all the assets within your project, and then you can go and find the ones that end with .cs, and then you can have a flat hierarchy of where all your scripts are, and then maybe you could do a live filtering typing thing where you type, SW, and then it'll bring you to the sword.cs. You can click on it and open it right away. So definitely within the realm of possibility.
Another super cool feature would be the ability to do something like on-scene GUI. I know you showed on Draw Gizmos and not on Scene GUI today, but something like that for the preview window would be spectacular. So as far as I understand it, the way previews work right now.
I think there might be something like on preview GUI. There you go.
Very possibly.
Okay, great.
Actually, I think that's...
Let me zoom in for you.
I think that you have to do an entirely custom preview to do that.
So you just want to draw something on top of the existing preview.
Exactly. Like basically consider the existing preview like a 3D scene would be fantastic.
I see. Cool. Agreed. Anyone else? Yes.
So we were trying to get Fmod working in Unity using the SquareTangle plugin, and I originally wrote a program in Java to take the Fmod programmer file and parse it all out into a C# file which would work in Unity. And we're working on, I'm about halfway there now, of creating a tool in the editor to take that text file and transfer it to
convert any Java file into a C# file?
not a Java file, it's a text file, so it's just plain text.
Oh, I see.
I wrote it originally in Java, which was clunky and hard to use outside of the editor. So that's what we're working on now.
Very cool. Anyone else? Yes.
I really would like an editor script to do a better job of previewing vertice binding on skin meshes and then updating them if for some reason there's like a small imperfection instead of having to export it all over again. So,
What did you say about vertices?
on skin meshes to preview the vertice to bone binding.
To the binding, I see. So which bone it's
Yeah, and like
bound
the
to?
percentages and then possibly being able to update them. Especially when you go to different platforms, sometimes you can only do 2 and then the skin mesh looks
Sure.
very different.
Absolutely. So I think we have access to the bone weights, right? So mesh has a bone weights value of each vertex, but how do we know which bone that weight is for? Maybe there's a way, but I haven't worked with bone weights much. I don't, or skin mesh renders that much, but there might be a way using this. And then maybe you can have a custom shader where it actually, just like in a 3D application, if the bone weight is 1, it's green, and if it's 0, it's black or something like that.
Thanks.
So it should be possible. Anyone else? Okay. Yes.
Is there a way to use the mesh, the painting tree to paint a custom mesh over another mesh?
Yes.
Except a terrain.
You're talking about where we were talking about the trees and you can paint over the terrain?
Not the terrain. I mean, if, for example, if it's a box or any other object.
Yes, absolutely.
You use another object to just paint.
Yes. I'm trying to remember what method, whether I actually used a raycast in the scene. I did. So you can pick something in the scene view without doing a raycast, or maybe internally it does a raycast, I don't know, but there's a pick game object method. I think it's in the handles class, which I actually meant to talk about. The handles class is really, really good for on-scene GUI. So remember in Polyline Editor, we had some on-scene GUI stuff. And we were using the handles class to draw buttons and so on and so forth. And there's a lot of stuff in the handles class for this. And in addition, there's the handle utility class, which I think in this one is the method to pick a game object. Yeah, pick game object, pick record objects, etc. But pick game object, you give it the mouse position and pick something for you. It doesn't say where you hit the game object on. So for that, you need some kind of raycast so you know where it hit. And then in that position, you can spawn your object. So if the mesh that you're talking about has a collider on it, which you can just achieve with a mesh collider, then absolutely. Cool. Does anyone have any questions related to the things I've shown so far? No, well, if that's it, then that's it. Thank you very much for attending. Oh, real quick, I have the link to the info page for this talk, just bit.ly/editorscripting13. If you go there right now, there isn't much to see. It's just 3 links to editor scripting related talks from the past 3 years, but as soon as the conference ends and I have some time, I will be putting the Unity project that I used for this presentation up there, minus some of the stuff I can't release, such as the golf stuff, because that belongs to the client. Thanks.